Hello, I'm Cheryl. In this problem, we're going to be using the method of Lagrange multipliers to help find the minimum of my function f of x y equals x squared plus y squared with the constraint that x plus 2y minus 5 has to equal 0. I'm going to begin this problem by writing this constraint as a function of both x and y. So I'll write g of xy equals x plus 2y minus 5. Now, in order to use Lagrange multipliers, I have to make sure of a couple of things. First of all, my functions f and g have to have continuous partials, which they do. My constraint function also has to be a smooth curve, which it is. The last piece that I have to check is I need to make sure that the gradient of g is not the 0 vector at my solution point, and I'm going to check that a little later. So let's go ahead and take a look at the method of Lagrange multipliers. What I have to do is I'm going to solve the equations that the gradient of f at xy is going to equal lambda, which is my Lagrange multiplier, times the gradient of g of xy. And I also have to state that g of xy is going to equal a constant. So for this particular problem, the first thing I need is the gradient of f. So that's going to be 2x times my vector I plus 2y times my vector j. That should equal my Lagrange multiplier times the gradient of g. And the gradient of g is just going to be I plus 2j. All right, now one thing I mentioned before is that gradient of g could not equal the 0 vector at my eventual solution point. Well, look, here's the gradient of g, and it's never going to be the 0 vector. So that third condition is certainly going to hold here. All right, so what does this tell me? Well, because I have two vector functions that are the same, their components must be equal. So let's write this as 2xi plus 2yj equals lambda I plus 2 lambda j. And now I notice that if my components are the same, that's telling me that 2x and lambda have to be the same thing. So I know that 2x has to equal lambda. Additionally, 2y has to equal 2 lambda. So I know that 2y has to equal 2 lambda. And I also know that this function has to equal c. So I have x plus 2y minus 5 has to equal my constant 0. I now have 3 equations and 3 unknowns. So I'm going to be solving this system of equations. So if I look at these two together, I can say that 2y is going to equal 2 times lambda. But according to my first equation, lambda is the same thing as 2x. So that means that 2y equals 4x, and that y is the same thing as 2x. I'm then going to take this information and plug it into my third equation. So I have x plus 2 times y, which I'll replace with a 2x, minus 5 equals 0. That gives me x plus 4x minus 5 equals 0, 5x equals 5, and x equals 1. All right, now I need the y coordinate. I know that y is 2 times x, so that's 2 times 1. So the y value is going to equal 2. So I know I will have an extrema at the point 1, 2. By looking at the original function and its constraint, I know that this particular function won't have a maximum. So that means that there's going to be a minimum at the point 1, 2. All right, well, the problem actually asks to find that minimum value. So in order to find the minimum value, I have to plug 1, 2 into my original function. So f of 1, 2 is going to be 1 squared plus 2 squared, or 1 plus 4, and the minimum value that this function takes on with the given constraint is 5. I hope that was helpful. Thanks.